Welcome to today lecture. Myself, Dr. G.V. Chandra, Assistant Professor at SR University in the Department of Civil Engineering. Today means we will discuss about the introduction to wastewater treatment. So means why we need to treat the wastewater. That is the means one question. So why we need to go for the treatment? So first of all, everyday usage, we are taking draw water from the lakes, rivers, maybe from the aquifer. So everyday usage, we are consuming around 135 to 200 liters per head per day. Uh, so we are using this many liters of water every day. That means after maybe 2 or 3 decades, no fresh water is available for the drinking or other purpose. So we need to limit the usage of water. If it is not feasible, then we need to go for the treatment option. That's why this subject is very important in the environmental aspects. So, what are the sources? Now means what the sources, what is the importance of wastewater treatment, why we need to go for the wastewater treatment as already discussed. And now means we need to discuss about the sources. What are the sources? Domestic wastewater. So means domestic wastewater means what are the water is coming from the households. That's called as domestic wastewater. Then industrial effluent for making of any product is required water. After usage of this water, some water is turned as the contaminated water that we called as wastewater. So as for the industrial standards, industrial requirement, they are using the particular amount of water, then leftover water is the wastewater. So as for the guidelines of government of India, we need to treat, then only we need to dispose on the water bodies. So that is the kind of wastewater generated from the industry. Next one, the stormwater runoff during the rainfall. So what will happen? So entire water will be flows on the road. It contains dust and other impurities. It will be dissolved in the water itself that turned as the wastewater. So those wastewater also we need to treat. Then agriculture runoff nowadays see means many of the people for betterment of yield purpose they are using different means to pesticides. So what will happen if they are using the different kinds of pesticides? What will happen? The water also get contaminated. So these are the means general sources of wastewater. So what is the importance? So if you're not treating, what kind of effects on the environment as well as on the humans? So first one is the it prevents waterborne diseases. If you are not taking the water that contaminated with the other metals, maybe other means kind of parameters, then it won't means cause waterborne diseases. Then next one is the if you are treating, then protects surface and groundwater quality. Means if you are treating, what will happen? The quality won't change. Surface as well as the groundwater. Reduce the environmental pollution. Ultimately, if you are reduce the contamination, ultimately it will be means protection of environment only. Enables water reuse and resource recovery. So means before treating, one option is the reuse. If we are reuse means we need not to take means fresh water from the water bodies. That is the importance of wastewater treatment. So generally in wastewater treatment there will be different stages existed. Means primary, secondary, and tertiary treatment. Here in coming to the primary, the physical removal of solids. So that is called as under primary treatment. Coming to the secondary, what about the biological matter that should be degraded by microorganisms? That is called as secondary treatment. Tertiary treatments means it's required advanced level of treatment Those things we'll discuss later. These are the three basic stages of wastewater treatment. So, what are the primary treatment units? So here this primary treatment is generally called as first stage of treatment. Here generally removes large floating and suspended solids, reduce the load and secondary treatment. The mainly physical process. Here for suppose the large floating objects are there, and also suspended solids also there. If you are not removing, then this wastewater you are sending to the secondary treatment unit. What will happen? Load on the biological treatment so that it fail easily. So first of all, what are the physical objectives that should be removed in the primary treatment? Then only we need to go for the second treatment. So in primary treatment, what are the units existed? First one of the screens. What is the advantage of the screens? Remove large debris. Grit chamber remove sand and grit, and sedimented tanks here settled suspended solids. Skimming tanks purpose is the removal of oil and grease. I will mention briefly about these units. We will discuss in the coming lectures. So screening here the maybe means what are the wastewater is contained, paper, plastic. These are the kind of large objects. It is floats on the surface of the water. So if you are providing the screens, so what will happen? Means when water flows through the screen, the large objects will be stopped here. So, so that's why we are using the screens. Next one is the grid chambers. So we, as we discussed, the sources of wastewater, it may be stormwater runoff. Stormwater runoff generally it carries the sand particles. Whatever the particles exist on the road, it can carry it during the this runoff. So we need to means reduce this sand particles, some kind of little bit more kind of pebbles we need to remove. So that's why we are choosing grid chamber. Next one will be the suspended particles. Here means first two units is remove the kind of objects, maybe papers, plastic, some kind of sand grid particles. So here basically sedimentary tanks. So purpose is to settle the suspended solids. Here we are providing some kind of detection time. So for suppose I am providing the 20 hours detection time. What is the meaning of that one? So initially, what are the wastewater is coming to the particular sedimentary tank? We need to wait up to 20 hours. Then only we are means after 20 hours we are sending that supernatant liquid to the next chamber. Next chamber. So what will happen during these 20 hours of detection time? The whatever the suspended solids existed in the water, it gets settled. Then last one with the skimming tanks. So generally means domestic wastewater contain the oils, and industrial wastewater also releases solids. First we need to remove the oil. If you are not removing the oil, what will happen? What are the water means air won't percolate in the means bottom layer of water. If air is not entering the water, what will happen? Means bottom side anaerobic conditions may occur. So that's why we need to remove oil. So next treatment will be the secondary treatment method. See here, so generally the secondary treatment termed as the biological treatment process. So main mechanism here will be the microorganisms that break down the organic matter. So if you break down the organic matter, what will happen? General organic matter contains BOD. Inorganic matter means BOD means organic matter plus inorganic matter. If you are degrading this kind of organic matter, what will happen? BOD and COD also will be removed significantly, and produce sludge as a byproduct. What are the sludge is produced? We can take and we can go for the means different kinds of treatment. The sludge, leftover sludge will be as the byproduct we can use for different applications. So what are the units existed for the secondary treatment methods will be the one of the most popular technique will be the activated sludge process. So what is the main mechanism here will be the we need to provide the aeration. So what will happen? Bacteria will be in the suspended state and whatever the organic matter present in the water also will be suspended state. So these microorganisms will try to eat the food in the means water, that is organic matter. So is we are providing some kind of detection time also. What will happen here? That organic matter will be reduced, then growth of microorganisms will be increased. That means MLS concentration will be increased. So you are providing some kind of settling time also here. The whatever the means after taking the this organic matter, the microorganisms try to settle on the bottom of the tank. This is the main mechanism of activated sludge process. Next will be the trickling filters. So here it is the method is called as attached biofilm treatment. Here, so we are providing this is generally in a circular shape. So microorganisms are trying to means attach to the walls of reactor. So food will move one place to another place, that is organic matter. So what will happen here? Microorganisms will try to means take food from the water. So this also means after means layers of attachment, layers of different layers of microorganisms. After some time, it will be detached from the walls. This way means in trickling filters, efficiency will be around 70 to 80%. In aqueous sludge is around 85 to 90%. And next process will be oxidation ponds. Oxidation ponds is the natural biological process. The next one is the sequencing batch reactor. So these means these units will discuss in the coming lectures. So what is the tertiary treatment? Here, this is called as advanced level of treatment. Generally, this treatment will suitable for industrial wastewater. It improves the water quality for reuse. The main purpose will be the means to remove of nitrogen, phosphorus, kind of dissolved solids or pathogens. So means here main units will be the filtration, disinfection, reverse osmosis, ion exchanges. So means in filtration maybe sand or membrane filters used, and disinfection means here chlorination, UV, ozone. These kind of chemicals we can use and to uh, kill the bacteria. Reverse osmosis here. Main objective will be the removes the dissolved solids, ion exchange, removes the specific ions. So this is the typical layout of wastewater treatment. So here means we discuss preliminary means it's a kind of Raci screens and grid chambers we are using as a preliminary. Coming to the primary, here will be the primary sedimenting tank, but means we discussed primary. So if the primary will comes under screen grid chamber primary. So here is specifically we mentioned preliminary. Preliminary means whatever the floating objectives we can remove, that is called preliminary. So after giving of detention time, suspension solids get settled. That is called a primary sedimentation tank. Here secondary treatment means in this picture we mentioned a activated sludge process. One will be the unit, and the next one is the aeration tank. Then finally we are providing some kind of clarifier. After that, if it is required, we need to go for the tertiary final effluent. See here means whatever the sludge is formed in the secondary clarifier, we are sending back to again to the aeration tank. If it is excess, we are sending to the sludge digestion tank where it means dewatering of sludge. Then remaining sludge we can go for the different treatment approach. Then this sludge will be used as a byproduct for another making of product. Then this is the final typical layout of wastewater treatment. So coming to the screening, so see here, screening is a device with opening for removing bigger suspended or floating matter in a sewage, which would otherwise damage equipment or interfere with the satisfactory operation of treatment units. That's why means we are going for the screening. So here different types of screens available. That is a core screen that is called as bar screen. So also called as racks used for removing large floating and suspended matter. Is a core screen means the spacing between the screens will be larger. That's why it will be removed only larger objectives. The C is the opening size also mentioned, 75 to 150 mm. That is the core screen size. So before pumps, then before sedimentation tanks, it will be around 50 mm. So usually hand means it will be means clearly visible. We can remove with the hand, sometime with the mechanical cleaning also possible. Cleaning devices include racks for removing collected solids. So what could be the angle we need to keep the screens will be around 45 degrees to horizontal. It improves cleaning efficiency. So next pass cleaning opening 25% more channel than the cross sectional area. So means core screen over next one is the median screen. Here opening size will be 20 to 50 mm. So bar typically 10 mm thickness and bars taper toward downstream side and bars are rectangular in shape. Larger dimension placed parallel to the floor. So next one is the fine screen. Here less than 20 mm the opening size. So always you should be removed through the mechanical clean only. Use it for removing very fine particle. Not commonly used for the sewage due to the high chance of clogging. So generally means in means screens means it removes the means objectional solids. So in that three types, one is the core screen. Here is greater than 50 mm. It can be removed there. If it is between 20 to 50 mm, we need to go for the medium screens. If it is less than 20, we need to go for the fine screens. Generally, these fine screens won't useful for the wastewater. It is for the some other purpose. Means generally, if you are using these kind of fine screens, before that it will clog the secondary treatment also. So this is the typically cross-sectional of screening. Then here see the means bar is provided around 30 to 60 degrees angles. So next one with the grid chamber, the preliminary treatment unit in wastewater treatment located after screens and before primary sedimentation tank. So what is the main objectives of this grid chamber will be the removes inorganic particles. So what are the inorganic particles? Sand, gravel, silt, broken glass, eggshells. These are the kind of inorganic particles. What is the purpose of this grid chamber? So prevents abrasion of pumps and equipments. If kind of sand particles or gravel particle is there, then we need to send water to the pumps only. The pumps will be damaged. Then avoid deposition in pipes and tanks. Unnecessarily it will be occupied and capacity of the pipelines and damaged very quickly. And reduce load on the downstream units and maintain smooth operation of treatment. If we are doing this kind of particles removed, then it should be smooth operation for the further units. So what is the design criteria? So here the flow velocity mass should be maintained 0.15 to 0.3 meter per second. Then velocity must be here low enough means allow grid settling. High enough means prevent organic settling. Generally, detection time it is around 30 to 60 seconds. So here also grid chamber will be the means divided into three types. One is the horizontal flow grid chamber. Here means horizontal flow means flow moves horizontally. Velocity controlled by channel design. The simple and commonly used this type of grid chamber. And aerated grid chamber. Air is supplied here to create spiral motion, keeps organic matter in the suspension, improves grid separation efficiency. Coming to the vortex grid chamber or circular grid chamber, circular tank with a rotational flow, grid settles at the central bottom, compact and efficiency. So coming to the one numerical problem, see here, a waste water treatment plant receives a flow of 18,000 meter cube per day. Design a horizontal flow grid chamber assuming the following factors. See, flow velocity 0.25 meters a second, detention time will be 40 seconds, depth of flow will be 1.2 meters. And here we are asking to calculate the cross-sectional area of chamber, then width of the chamber, length of the chamber. So here we need to calculate the dimensions of each chamber. So what are the given data here? Flow will be the 18,000 meter cube per day. Velocity should be 0.25 meter per second. Detection time will be also providing 40 seconds. Depth will be 1.2 meters. These are the given data. These are the given data. Then, so we need to convert this meter cube per day to meter per second. So step 1 will be convert flow into meter cube per second. Here is 18,000 per second means how much means per day, how many minutes? One day means 24. So here 24 24 hours, each hour contains 60 minutes, each minutes contain 60 seconds. So if you are multiplying 24, 60, 60 will give the 86,400. Then final it should be 0.208 meter cube per second. So now we need to calculate the cross sectional area. What is the cross sectional area? Generally cross sectional area should be L into B or B into depth. Cross sectional area means B into depth. That is called as cross sectional area. So here cross sectional area will be Q means water flow divided by velocity. So Q means here we calculated 0.208 meter cube per second. Then velocity will be here 0.25 meter per second. Now is calculated cross sectional area will be 0.832 meter square. So next one will be the we need to calculate the width. So how to calculate the width? Width formula we know. So width equal to area divided by depth. Depth is given in the question 1.2 meters. Then width equal to area here 0.832 divided by 1.2. It gives around 0.693. It is rounded off to 0.7 meters. So next we need to calculate the length. How to calculate the length? So length, for calculating our length, it should be a velocity multiplied with the detention time. So velocity should be 0.25 meter per second. Then detection time will be provided as 40 seconds. Here is the length will be 10 meters. Now you calculate the length, width, depth already given in the question paper. So calculated width will be the 0.7, depth is given as a 1.2 meter, length is given as 10 meters. So we need to go for the cross check whether means our calculator value is correct or not. So Q equal to area, how much we got? Around 0.832 meters square. Velocity we know it is around 0.25. So the discharge will be 0.208 meter cube per second. This is the correct. Means whatever the calculation will be correct. So This is the one of the important design, how to design a grid chamber. So first we need to calculate the cross section area. After that we need to calculate the width. After calculating the width we need to calculate the length. So these three parameters needs to be calculated. So what is the flow equalization? Generally means in wastewater treatment means the purpose is to run the means every day. So means in summertime means people are using the more water. In winter time means comparatively summer very less quantity of water usage. Stew means balancing these kind of means irregular. So we are going for the flow equalization tank where means we can store water. We can store water whenever excessively water is coming to the treatment unit. So whenever water is not coming, that time we can treat this wastewater. That is the main purpose of equalization, as well as the one of the means major objective of this flow equalization will be the means combination. If we can combination of different wastewater, so that the dilution of concentration will be also means happen. So this is the main objectives of the flow equalization. Here it is mentioned process of controlling flow rate in wastewater treatment, prevent sudden surges, high flow variations, avoids washout of solids and organic matter, ensures uniform flow through the all treatment units, provides sufficient time for physical process, biological process, chemical process. So what are the different types of equalization tanks? Flow through type. Here outflow should be equal to input flow, generally used where equalizing the concentration, self neutralization as I discussed previously. It is not suitable for flow balancing. So it is not suitable for flow balancing. Intermittent flow type. Here uses two tanks alternatively. One tank fills, tested, emptied. Secondary tank operates simultaneously and suitable for small scale industrial flows, and it is the economical option. So variable inflow, constant discharge type. Inflow varies but outflow is constant. So controlled using the pumps. Suitable for large wastewater flows. Tank size determined using the cumulative inflow versus outflow graph. So what are the design considerations? Here, detention time will be provided 2 to 8 hours. Then it sometimes go for 12 plus hours also. Larger detection time may be used aerated logging systems. The capacity based on flow variation analysis and safety factors. So, so what are the things we discuss today lecture will be why means why we need to go for the wastewater treatment. So what are the units existed? The primary, secondary, tertiary treatment. Primary, secondary treatment generally used for the domestic wastewater treatment. Or if your means wastewater contains some specific contaminants that won't remove by the secondary treatment, then only we need to go for the tertiary treatment. So this is called a special treatment or a specific treatment for removal of uh, specific contaminants. So in that we discussed screening, equalization tank and grid chambers. We discussed around two numerical problems, how to solve the means grid chamber design. That is the most important, how to calculate the dimensions, means these things we discussed. So in coming lecture, we need to discuss about the further units. Maybe we will discuss about the primary sedimentation tank, then how much reduction time we need to provide, how to design the primary clarifier, and what are the dimensions, what could be the flow, what could be the horizontally flow, then what are the secondary treatment units, those discussions and design parts and tertiary treatment, some of the designs also we need to discuss in the upcoming classes. Thank you very much.